Hello all. Hope all of you are doing well in this pandemic situation. A quick introduction about myself. I am Vigneshwar Sethuraman. I did my master's in Information Systems Security Management from Concordia University of Edmonton. While doing my master's, like research in master's, I performed an experiment on Snort Intrusion Detection System, where I was running multiple test case scenarios and deployed it in multiple environments and testing it out and checking out whether how much efficient it is able to perform in each environment. And then I was writing the rule sets for different traffic, and I was checking out with multiple attack cases like that. So today presentation is about my research work that I performed as part of my coursework. So yeah, let's jump to the presentation. So today's agenda is going to be like overview of intrusion detection systems, snort snort implementation, test case scenarios, existing vulnerabilities, and then proposed solution. Like in proposed solution, I just came up with a simple solution that I proposed in my research work, so I'm going to share that one. Yeah, so overview of intrusion detection system. Like there are multiple types of intrusion detection system. Like the most common one are in network-based intrusion detection system, host-based intrusion detection system, hybrid-based intrusion detection system. So network security, like it has surpassed host security with the increase of networks globally and the need for packets to reach worldwide. A network intrusion detection system can detect a broad range of malicious and unwanted attacks compromising the application network and transport layers together with unexpected services supported multiple applications. And network-based intrusion detection system is mostly for network-based attacks, or like it will be placed in the I mean situation where we want to monitor the network traffic and what the content that is being passing in the network side. Whereas if you come to host-based intrusion detection system, like we when compared with network-based, host-based will mostly focus on the particular host or particular endpoint in the network. So the host will just monitor the functions or processes, system processes, traffic going in and out of that particular host. Like host based is just confined to towards that, and it won't do anything more than that. So as opposed to the detection of the network based intrusion, host based intrusion detection, it protects the individual endpoint system in the network. It inspects the network interfaces, malicious file access modification, configuration changes, application activity on the host, and then it later analyzes the log that each component generated. From then it will compare it with our own trained data sets. If the match happens, then yeah, it will alert the administrator about that. Then okay, there comes a situation where we cannot just use NADS or HADS separately. We might need both the NADS and HADS in that case. So instead of using it both, like we came up with hybrid based intrusion detection system, which has both the functionalities of network based and host based system. So yeah, so that is what hybrid based intrusion detection system. And Snort. Yeah. So the Snort is an open source intrusion detection system that is a rule-based intrusion detection system. The local rule set we will define will be beforehandedly configured. I mean, from the traffic that is going to pass. So we will be sitting and analyzing it, the traffic, and then we will come up with the rules. We will mention it on our Snort rules file or rule section, so that Snort can able to see and compare the traffic with our own defined rule set, and then it will generate the alert accordingly. So Snort can be deployed in three modes, like packet sniffer, packet logger, and network traffic debugging. Snort can also enable application detection and then also filtering. So this is my Snort implementation that I performed in my local environment. So here you can see that Snort has two things: pre-processors detection engine and then it also has rules. So Snort will invoke rules from this rule section, and it has both preprocessor and detection engine, which will parse the rule section, and it will process all the traffic that comes in the system, and it uses preprocessors and detection engine to process it, and it will give a unified output from that, which will be given as an input to Barnyard 2. So Barnyard 2 will then generate the output, and it will give a load the output into the MySQL server. From MySQL server, we can able to view the Snort output data in a browser, our web browser. Like we have several engines like Base, Kibana, like that, from which we can able to view our Snort produced output in a more user friendly manner. So that's what we are using, and we are using web server for that purpose. So these are some of the screenshots I kept. Like here, I installed Snort in Kali Linux, so I am verifying that Snort has been installed perfect. I mean properly or not. Like I verified that using Snort -v command, and then this is my Snort uh, snort.config snort configuration file. So here we will mention the IP address of our home network, IP address of our external network, and then DNS, SMTP port address. Like we will mention everything according to our environment configuration in this snort configuration file, so that snort can able to know which network it is monitoring, which host it is monitoring, and what environment it is currently monitoring, like that. And this is the MySQL database I created. So the table file, which has several columns in it, like data, detail, encoding, like that. So the Snort comes along with pre-installed with schema, database schema. So we don't need to create a newly database table from scratch. We can just invoke the database schema that Snort comes with into our MySQL database creation, and all the fields or columns will be automatically built in this table. And this is my Snort log directory. So here you can see /var/log snort. Here the snort output log files are present in this directory. So I kept that screenshot. So this is my local rule file that I may have kept. So here I wrote some rules for my lab environment. So you can see that alert ICMP any to any, and I kept a message inside that along with snort ID and revision number. So what it will do is, if the snort see any ICMP traffic that is going in our network from any destination source IP address, source port number to any destination IP address, any destination port address, it will give this message like ICMP testing route. And yeah, that's how we will get an alert in our machine. The snort ID and revision number is like snort ID is a unique identifier which will identify the particular snort rule in our machine. And the revision number is like, if we have for instance, if we create a snort rule set or rule file right now, and after a few months, if we want to update or modify the already written alert rule file, then yeah, we can mention that one as the revision number 2, because in order for us to easily differentiate between the multiple versions of our rules that we are going or writing in the rule set. So that's what these fields are about. And then yeah, so these are the test case scenarios. I performed like 4 test cases scenarios for this presentation. So the attacker IP address I used was like, it has an IP address of 192.168.72.134, and the snort installed IP address was 192.168.72.138. So the first test case scenario was nmap TCP scan. So here you can see that I performed the nmap TCP scan with port 2022, on attack Snort installed machine. So I'm getting the status of that port I mentioned, like here iPhone port 22. It says that it is closed, and I can see that this thing it came up here like Nmap TCP scan alert has been generated in our Snort installed machine along with the IP address from where the request came to where like source and destination IP address along with the port address of that request. So this is my first test case scenario. So second test case scenario was like I did a Nmap Xmas scan. So what is that Nmap Xmas scan was? Usually the TCP handshake involves three flags like SYN, SYNAC, and ACK. But if we can able to do Nmap Xmas scan, which is kind of a stealthy mode where we can able to deceive the receiving end about the kind of Nmap scan that we are performing in order for to easily evade the security control that we kept. So if for that case we can use Nmap Xmas scan. So it uses three flags like FIN, PSH, and your urge flags. So yeah, this is that Nmap Xmas scan that we performed. So here I am doing Nmap along with the options of -SX, and I am using same port 22 and the Snort installed IP address. And I'm getting the response back as the port is closed and along with the service that is running in that. So here I can able to see that the alert see here Nmap Xmas tree scan TCP along with the source IP address and destination IP address and port address of the corresponding traffic. This is my second test case. And my third test case was I'm doing a FTP connection from my attacker machine to the Snort installed machine. Here I'm doing FTP, giving the IP address of the Snort installed machine, and I'm getting the response back as FTP connection refused. So I can show you that the alert has been triggered here, like FTP connection attempt, along with the IP address port number of the source and IP address port number of the destination machine. This is my third test case. And my fourth one is denial of service attack, where I'm flooding the Snort installed machine with more number of packets that it can able to process it, and eventually it will be get over exhausted with too much of packets that it can able to process, and that's how the denial of service attack will happen. So here I'm using hping 3 from my attacker machine along with the port 80, and then I'm using flood. Then I'm using hyphen rand. So I'm generating a random source IP address in order to not get noted from the Snort installed machine. So here I can see the possible TCP DOS alert was triggered with the, if you can see there are multiple TCP DOS rule has been, alert has been created, in which each time a new IP address has been, source IP address was created, and it has been shown here. So this is my fourth test case scenario. And then I'm using, I mean, I performed base also. I installed a base in it. So here you can see the base I performed in my local browser using localhost 127.0.0.1. So I can show you the TCP traffic, UDP traffic, ICMP traffic, and the source IP address, destination IP. Like it can show you the overview of how much traffic has been generated and how many alerts has been created in the last 24 hours and in last 72 hours, like that. So it will give you much more user friendly view of the alert or traffic that has been present in our system. And then okay, then existing vulnerabilities. So the first one will be they're like it is difficult to maintain like huge set of rule set that we are writing in our environment. For example, if we have a like small environment, then might be much more manageable to write the snort rule set and maintain it accordingly. But if it's in a case of larger environment where we have more than 1,000 or 2,000 systems and networks that are happening, or that traffic is going on a day by day basis, then it's hard to come up with a new snort rule every day for every new attack or malware thing that is going on. So in a longer run, it might be much more difficult to manage and maintain it as a whole, and it will be much more tedious to keep track of particular snort rule or from which snort rule the alert has been triggered like that. It might be much more harder for that case. And then the next one will be might generate a lot of false positives and false negatives, which has to be prevented, or else it might be harder for network administrators or system administrators to look over it and then find it whether the alert that was triggered is a legitimate or is it a malicious one like that. And yeah, the third one will be in some situations, the attack, like the attacker is assumed to be directing the attacks from multiple sources in a layered manner. So in that case, the IDS cannot able to properly identify the traffic or classify the traffic, or else if attacker like advanced persistent threats like very complicated attacks has been performed or initiated against the machine, then the snort cannot able to correlate between multiple connection or endpoints and to form a big picture of what is happening in the network like that. And the fourth one will be encryption. Like we will in some situations like SSH or SSL where the traffic is traveling in an encrypted format. Yeah, in that case, ideas will be much more harder to see what is present in the packet inside that tunneled traffic like that. And the obfuscation by path manipulation. So, for instance, the path, uh, any path that has been mentioned in the script that is being passed from the outside network to the internal traffic. If any script is passed as the process of traffic passing, the path traversal has some unique meaning for each kind of a card script that we are writing. So the snort might not know the exact meaning or intended meaning for the path command or the script that has been written. So like it might consider it as a legitimate path traffic, I mean path script that is coming from the outside network, and it might even allow it. But actually the intended meaning was something else, and Snort couldn't able to differentiate between that, and hence the attack might even become successful. Yeah, so few possible or proposed solution was like we can use either parallelism or multi-threaded. Like Srikata is a multi-threaded engine, which means that it has more than one core in its CPU. So it can able to process the traffic much more faster and in an efficient manner, and it is mostly preferred for signature based intrusion detection system because if you have a high network traffic where a lot of traffic are passing in and out, and it's hard for the intrusion detection system to keep track of all the traffic that is passing, and the bandwidth and the network utilization might even get deferred based on the the core of the CPU. If it's a single threaded, it might become even slower when traffic increases. So in that case, multi-threaded is much more preferred and helpful. And yeah, we can use unified threat management. Unified threat management is like having a single appliance which has multiple security features in it. Like for example, firewalls, routers, intrusion detection, intrusion prevention, URL filter, content inspection, malware inspection, like that. It comes with everything in it, and it's much more cheaper to use it, and yeah, it's much more economical. And we can also use anomaly or behavior based, whereas like we will train the machine, or like we will do a learning period for the data sets, like trained data sets. We will make the machine to observe the normal flow or the normal traffic in order to form a baseline. So when it gets that baseline, then it can easily able to identify if the workflow or if the traffic flow deviates from that baseline, like observed baseline, that is the anomaly or behavior based. And yeah, this is my possible, like I came up with this, like I gave up the solution for my research work. Like what I was proposed was, like I gave a central logging system. So like that central logging system will be present in intrusion detection system. So in which all the individual network components such as servers, host, firewall, monitoring devices, everything, it will log the data and it will pass it to the central logging system instead of like each component able to process it like individually. So that is the main feature in my proposed one. So and then because the individual component are ineffective in analyzing and categorizing it. So if a central logging system is there, it will take the final call whether the traffic that it gave is a malicious or is it a legitimate one. So the central logging system, it is configured with a central fuzzy logic server, which I configured using decision tree classifier algorithm to identify and classify the possible common attacks in each host in the network. And so it performs the better classification in detecting the malicious attack attempt on the missions from the attacker. For instance, like specific software or protocol running on any version in a operating system leaves an audit trail of data for detectors to identify it. So every component and subcomponent is a multi-threaded, so that it can able to process it like more than one process at a time, and it saves a lot of time also, and it also prevents the bottleneck situation where if all the traffic are being imposed to just only one machine in at a time, then other all the traffic has to wait until the previous one gets completed. So it might create more bandwidth utilization, and the performance will be much more impacted in that case. So that's why we are using a multi-threaded processor to avoid the network bottleneck situation. And we are also and I also gave a load balancer and packet duplication checker in order to overcome the repetition issue. So once the threshold is reached in a particular component, it will redirect that packet to the next available component, and that might prevent a deadlock situation from happening. So several components are installed along with this main component. Like if we might even have IPv6 network or IPv6 IP, I mean traffic coming through our network. So in that case, it might even make sense if we have additional preprocessor for IPv6 encapsulated packet in an IPv4 network. Visualization platform in a Snort engine for effectively managing the alerts and rules in the network, reducing the rule management overhead. So um, yeah, so this is my presentation for today, and I hope all of you got some insight and information about Snort thing. And I'm aware this is my first presentation or first talk in BSides event, and I'm very happy that I was part of BSides Vancouver, and I thank the presenters and the event organizers for giving me this opportunity, and I'm glad that I can even do the same thing like next year also. Thank you, and good luck to all of you all.